These are a bunch of my old physics notes. This one is actually the oldest of all of my notes actually. It's copied from the book Quantum Physics for Dummies, and I was looking through my notes the other day and I thought this would be a nice video to make and show you my reactions to my old notes. So yeah, I started this in 2019, December of 2019. I was 14 years old here, and I remembered I actually borrowed this book from the library. And since obviously you can only borrow a book for so long, I decided to copy the book down so that I could study it in my own time. It's not a great book. I wouldn't say it's for physicists, it's more for enthusiasts, or maybe even it was suitable for a kid like me. It does try to present everything in as simple of terms as it can. It was quite interesting nonetheless, and my handwriting looks very different back then than it does now. It's amazing that I managed to copy so much in such a short amount of time. I believe I only was allowed to borrow the book for about 3 weeks or up to a month. I believe I extended my borrowing period to about a month. All right, let's look at other stuff. This is actually recent. This is a bunch of rough notes that I'm writing while I'm doing my project right now. This is a bunch of it's just a bunch of plain white paper. I binded a book out of this. It's my first ever book binding. This is my first ever bounded book. So right now this book is not really being used. I've just been drawing faces on it. Like, it's not very good. I'm not good at drawing, but that's how it looks like. This is supposed to be like Leonardo DiCaprio. That's Daft Punk. I believe this is Cillian Murphy, but it doesn't look like him. This is Oppenheimer, yeah. That's Walter White. That was like a random drawing. Anyways, that's not physics notes, let's put that aside. This is a huge chunk. What's this? 801, 802, and 803. Professor Walter Lewin. I watched his lectures during the quarantine, and these are my notes from that time. You can see the handwriting is still like that. Slowly the handwriting will evolve and you will see that it becomes more and more cursive. They're falling apart right now. It's really bad. So let's put it back before it falls apart even more. What do we have next? Scrapped projects. Yeah, I studied a lot of things outside of just the standard classical mechanics, relativity, and quantum mechanics. This one is 1801. I believe it's Calculus 1 from MIT OpenCourseWare. Calculus 1 is very easy to get, so there's really no need to create such detailed notes. I guess that's why I scrapped the project, because I already understood everything there was to understand, and creating nice notes wouldn't really serve me a purpose, because these are things that you don't really forget. Like, you don't really forget this, so like, why would you need notes on that? Fluid dynamics. I believe this was by an Indian professor. I forgot his name, but he was a really good lecturer. This is surface tension, I believe. This is the next one, 806. I believe this is about perturbation theory. Yeah, this whole course was on perturbation theory. What does this say? Look at my handwriting, it's really bad. Weak Zeeman. Yeah, it's about perturbation theory, the Zeeman effect. Let's see what we have next. 805, harmonic oscillator, Heisenberg equation of motion. I might make this video into a part 2, so maybe I might do this box today, and then another day we'll do this box. That is 804. I recently watched back some of the lectures from 804, especially the first lecture in 804. He says at the start of the lecture that the first lecture was meant more for philosophers. There's like completely no math in this, and he just goes on and on about mutually observable properties of quantum objects. Really, you can boil this whole hour-plus lecture down to the fact that some operators commute and some operators don't commute, and that affects whether they are mutually observable or not. That's it. And I think he could have simply summarized this whole lecture up in a few sentences. So I don't really like the first lecture, but the rest of the lectures are actually okay. I mean, they cover like square well and whatnot. It's a very simple introduction to quantum mechanics. I believe we have some more miscellaneous notes. Alright, I think I know what these notes are. This one is on biophysics. And biophysics is actually a really interesting topic. Most of it is actually just statistical mechanics applied in a biological setting. I actually mentioned biophysics in my university admissions interview, and I think that helped me stand out because the professors who were in the interview actually really liked it. For once, they're not listening to someone just talk about how they like relativity and quantum mechanics and astronomy. Yeah, and here it talks about open and closed channels in like the cell membrane, and it talks about how the electric potential actually causes the channels to open and close. And it's really interesting stuff. I wish I had studied a little bit more, but honestly, I don't really have the interest or time to study biophysics right now because I'm doing quantum field theory. If the opportunity presents itself again, I definitely would want to pick this up. What's here? Oh, so these are quite recent. These are from like the last year or so. Yeah, these are Paskin and Schroeder notes. And that's the end of the first box. This next box, I'm actually not so sure what's inside because I also haven't seen it. But my guess, based on what I've seen here, that this one should contain quite a bit of multivariable calculus and also general relativity and special relativity. But that's for another video. So yeah, stay tuned. Alright, that's about it. Goodbye.